So we're going to start talking about soil. And so, maybe obviously, soil is the uppermost layer of the Earth's crust, and it supports life on Earth. Really, it supports plants, which then in turn supports animals and the microbes that actually live in it. And so there are a couple of factors that go into how soil forms. And we look at parent material, so what the soil is actually made up of, what kind of rock there is, bedrock, climate, so warm versus a cooler climate, wet or dry, topography, so the physical features of where that soil is, what organisms are living in and around it, and of course, how much time um, it's taken to form. And so the parent material, like I said, is referring to the rock and minerals where the soil came from. And so here's actually a map of Connecticut and what the bedrock is in that area. So if you're like super, super interested, you can look up your area here in Connecticut, um, here in Stamford, and figure out what the bedrock is made out of. And that parent rock has a very direct effect on the soil um, that around it. So, what is the texture going to be like? What kind of chemistry is going to happen? So, what reactions are happening within the soil, and all that kind of stuff. And so, it parent material could be native, so like was there, or transported by perhaps wind, water, or even deposited by a glacier when it was receding. And so after enough time, the soil may reach, some sort of equilibrium, a nice happy soil. And there are both biotic, so living, and abiotic, the non-living factors, could preserve or erode a mature profile. So, if there are worms crawling around in your soil, there's definitely going to be some erosion happening within this mature profile, and so there's going to be changing. So ultimately, the mature profile will actually change. Climate, of course, is super important. And so temperature and precipitation, that makes up climate. And they affect lots of things. So the weathering processes, whether they're fast or slow, how much wind there is, if there's lots of rain, right? The micro environmental conditions for soil organisms. So is the soil, does it reach high temperatures or not? Does it freeze? What kind of plants are going to grow there? Decomposition rates, soil pH itself, because obviously moisture can alter that. And then the chemical reactions that are happening in the soil can also be affected by temperature and moisture. And so, formation of soil is going to occur in areas where there is higher temperatures and more rainfall. So the hotter it is, the more rain that happens, you're going to have a higher rate of soil formation. So if you look at over here, you have the tropical rainforest soil here, right? I want to like draw your attention here because, right, you have this very, very, very small layer of organic matter, and then you end up with this very like non-nutrient rich or nutrient starved profile below it. So even though people would think like, oh yeah, there's lots of nutrients in the rainforest, there's actually not. This very, very thin layer is all that's there. So just keep in mind to go on a little tangent when this is uh, when this vegetation is cleared away, there's nothing holding the soil in place, and so you end up with a lot of erosion. Um, right? And here in the grasslands, you have very thick, dark um, humus layer. My bad. You guys are rubbing off on me. So depending on where you are, so grasslands in these biomes, temperate, desert, tropical rainforest, the formation of soil is going to be faster. Not talking about organic matter, but the actual formation of soil. Topography is going to matter, so physical characteristics of where the soil is formed, because if you look at a mountainous region, you have a lot of runoff coming off these mountains that's going to erode these mountains and ultimately going to affect the soil beneath it. And so depending on how your land looks will affect the type of soil that you end up with. And so, we've been talking about soil formation, and that wouldn't happen without weathering. And so, there's a difference between physical and chemical weathering. In physical weathering, you have temperature changes. Remember, physical weathering is not actually altering the rock in any way, shape, or form chemically. It's just a form of a change of phase, right? So, from it was a rock and now it's a little piece of sediment. And so chemical, on the other hand, is usually caused by water, and so right, it can be a chemical reaction within the rock itself. And so all of these physical changes are going to help break up the parent material. And so one thing I want to point out to you here is this freezing and thawing, right? You end up with water collecting in these cracks in the rock, and as water freezes, water expands, and so it forces the crack to come wider. And then as the ice thaws, um, the water will actually go further down into the crack and push it again. And these repeated thawing and freezing and thawing and freezing will cause the rock to ultimately break.